Welcome to ePathshala lecture series in computer science, and this is a course in cloud computing. Today we will continue our discussion as we have started in the earlier module with peer-to-peer networking system. So, these are the people who are responsible to develop the system. This is the development team. So, let us quickly look at the various objectives, learning objectives of this module. We will recapitulate about the what we learnt about P2P networking, and then we will move on to specific examples of all the types of networking examples that we have looked at. Example of DHT, which is distributed hash table, an example on how Napster works. This is an unstructured P2P networking. We will see how it works. Then we will see how Nutella works and how Casa works. We specifically have opted for these examples because they each of them represent one kind of P2P networking, followed by summary. So, let us look at the definition quickly on the definition of a P2P. It is a system that is a distributed system. So, peer-to-peer system is a distributed system consisting of interconnected nodes able to self-organize into a network topology with the purpose of sharing resources. So, it is a self-organizing kind of a distributed environment, not unlike as we distinguished between client server computing and P2P. And the objective, the major objective of P2P networking is that we want to share resources. What resources? Any resources. It can be any text content, or it can be any data, or it can be CPU cycle storage, etc. In such a way that it can readily adapt to failures and accommodate transient population. That means that it is something which is dynamic in nature. Nodes will come and nodes will go, and in that the sharing of resources should continue while maintaining an acceptable connectivity and performance without requiring or support of a global centralized server or authority. So, these are the important points, that it is a distributed environment, it is self-organizing in nature, it is meant to share resources, it is a dynamic environment where nodes will come and go, join and leave, and it does not require a centralized, like a client server environment, it does not require a centralized environment. So, let us quickly look at the classifications that we learnt in the earlier module. So, first is the P2P architecture. In that we said there is a structured P2P and there is an unstructured P2P, and in that unstructured P2P we saw that there are three types: centralized, decentralized and hybrid. So, today we will look at in this module we will look at an example of the structured how that works. Then we will look at each an example of centralized, decentralized and hybrid peer-to-peer. So, we start with the structured networking, P2P networking, which is the distributed hash table. Let me reiterate here that DHT is not the only example in structure, but this is the most popular method of lookup services. So, this is how the DHT, one method of DHT, which is a chord, this is how it works. Again, distributed hash table essentially gives the concept of consistent hashing and maintaining the nodes and the data using consistent hashing. Various mechanisms have evolved using DHT. Here we are using the example of chord. So, in chord what they do is they will store the node IDs in a logical ring. So, the node IDs, so therefore, there is a in consistent hashing there is a large key space. Now, this key space has to be the hash function has to map the nodes onto this key space and the keys or the data onto the key space. So, here in this example we are seeing that the key space is 1, 2, 3, 4, 5, 6 and all nodes have to map on these key space as their ID, and the data also has to map to this space. So, let us assume that initially that the data that are the node that are there are in position 2, in position 5 and in position 6. So, according to code, what they will do is they will share. So, 3 computers, 3 physical nodes are present in this whole key space. So, the IDs of these computers have been mapped to node 2, node 5 and node 6. How we generate these IDs? We can take any unique value of the node. It can be the IP address, it can be some other value of these nodes, and we can generate. But the mapping function, which is a typical hash function like SHA-1, we can use, and it will generate a corresponding ID which will be one of the values between 1 and 6 in our example. So, we give the IP address of a certain node, and the SHA-1 kind of a hash function will generate a value between 1 and 6, and accordingly we will place the node or think that the node has the ID 1, 2 or 5, 6 like that. So, here this node has been mapped to 2, this computer or a node has been mapped to 5, and this node has been mapped to 6. Now, what kind of data or keys will each of these nodes manage? That is also predefined by DHT. What it will decide is that data from after whatever keys are mapped after 6, not including 6. So, 6 to 2 is the interval, but without including 6 and including 2, all keys that will be hashed in this space, in this interval, will be stored in the node which is mapped to 2 or which has the ID of 2. What about 5? From after 2, all keys up to and inclusive 5 will be stored in the node having ID 5. Similarly, the node 6, all keys after 5 up to 6 will be stored in this particular node. So, this is how say initially in this space, in the key space of 1 to 6, we have only 3 nodes, and these 3 nodes IDs have been generated using the hash function, and the data have been the key space for the data have been shared by these 3 in this manner. So, it is easy to see that if now I have a data and I need to store the data, I will use the hash function to map the data to a specific key, and as soon as I obtain, say I obtain a value of say 2, then I will store that data in 2. If I have a value of say 4, then where should I store? I should store it in 4, there is no node. Then should I store it in some other node? Yes, DHT says that you store it in the next node whichever is available. In our case, it is the node having ID 5, and this is consistent with this fact that the data whichever will be mapped after 2 till 5 will be stored in 5, and when I map a data at 4, I store it in 5. So, this is how the data is stored. Similarly, a data will be retrieved in a similar manner. If I am looking for a data which should reside in say whose key value is given say by 1, then I should look for a node which has the space of 1, which will be node 2. Node 2 will have from after 6 up to 2 inclusive of 2 will have. So, this way it is very simple to decide where the data should be and decide where the how to retrieve that data using a CORD DHT used CORD. Now, what happens when a new node joins? Say in this example we are seeing that a new node has decided to join. One point to understand is that in all peer-to-peer systems, one of the nodes must be known to the querying node. So, if this node is trying to join the P2P network, it must know some node in the existing in the P2P network, and we using that. So, initially it has no data. So, we hash the say IP address of this node and we get a value of 4. So, we have to map this, this node should have the ID of 4. So, we have the ID of 4. Now, what data should be used for this particular node? We have to decide that, and who gets affected by that is the next node in the circle. So, this is the node 5 that gets affected. How does it share the data with 4? It will say that, okay, so from 2 to 4 inclusive of 4 exclusive of 2, the now node 4 will manage, and 4 to 5 this node will manage. So, this is how, without affecting the rest of the nodes in the network, we can easily identify which node should go where and how they should be reorganizing. That is why it is a self-organizing network. Similarly, if a node leaves, then also say this node wants to leave, then we have to distribute this to this node. So, this node passes the information to node 4 saying that I am leaving and you can take care of the data that I had stored. So, this way we manage a DHT. So, the issues are that a new node can join, a node can leave. Leaving also can happen suddenly without any prior information, or it can happen knowingly when a peer node does not want to continue anymore, it can want to leave. How to store data and how to retrieve data. All these can very easily be done, and a mechanism that most of the DHTs have is a routing table, which are typically called a finger table, and these finger tables will be stored in the nodes, and using that with the help of routing table they can easily find out. So, this much is for DHT, which is the structured. Now, let us move on to the unstructured network. The first example that we have is for a centralized unstructured, which is a Napster model. Now, what is the difference between a decentralized and from the unstructured is that in unstructured, all the nodes do not appear to have information about any other node other than the direct neighbors of that particular node. Using that information, an unstructured P2P model has to work. So, Napster is perhaps the oldest P2P environment that was created. It became very popular, and then it got into some problems because of the copyright issues. That is not part of our module discussion. So, here the providers will share their files after registering themselves with the Napster server. Since this is centralized, so they used a server. So, registering process, as soon as Napster client comes to register itself, a peer comes to register itself, then it has to provide the identity, its some own identity, and what are the files that are going to be shared. So, the Napster server does not contain the files. The files are still maintained by the peer that are joining. So, it is not the responsibility of the server to take the data and then share it. Then we convert a P2P to a client server, but P2P is maintained by Napster in the sense that data will continue to be with the with the peers, only the information about the data, which peer contains what data, is stored in the server. So, it does not store any data file. It maintains a list of providers who has some data to be shared, some files to be shared, and it acts as a gatekeeper, allowing a peer node to access another peer node, which is a provider. So, to discover the data, the servers are used or useful. So, here is an example where we have 3 providers which are trying to provide the data, and here is one Napster server. They all have to register with their location information and the data that they want to share, and now Napster server has the information for all these providers. When a requester sends a request, the Napster server looks up its own mapping mechanism and decides which node contains the data, and then sends the response to the requester saying that this particular node contains your data, and then it will be the responsibility of the requester and the provider to communicate with each other and exchange the information. So, this is how Napster works. Now, the problem of Napster is that it is a centralized server. So, what happens is all the problems of a client server is applicable, although single point of failure and bottleneck is not applicable to data, because the data is still secured in so many other nodes, but what is not secured is the indexing information that the servers were containing. So, in case the server fails, all the indexing information goes away. Again, nodes have to register with a new server, new Napster server. To do away with this problem, the next method, which is a Nutella method, which is a decentralized P2P, Nutella is an example of that, has been devised. So, this is a decentralized file sharing. These are the instructions that they use, or commands that this Nutella client server or peers will use. Ping is to say what normally ping is used for, that I am available. Pong is to decide whether some node is available or not. Query is to say that I need something. Query hit is to tell that I have what you need, and push is to push the data. So, since it's a graph kind of a structure, what it does is it creates a breadth first, it employs a breadth first search, and the query has a TTL, a time to live hop numbers, how many hops it should go before it dies down. So, when one peer generates a query using a query command, it also has to provide a value of how many hops you are ready to search. It is a flooding mechanism that Nutella uses. So, therefore, this TTL helps it to contain the amount of congestion. Let us look at an example. So, here is the P2P overlay, where we have all the there are 7 nodes, and let us say that node number 2 has a query that it's looking for file 1, and this query it will send to its own neighbors, which is 1, 3 and 4, and 1, 3 and 4 once they receive the query, they will send the query to their own neighbors. So, 4 will send to 7 and 6, and 3 will send to 5, and they will get back the answer. Now, let us imagine that 6 does not have the file 1 that is being looked for, but both 7 and 5 contains the data. So, what they do is they send back a query hit that yes, I do have the required file, and then in turn 4 and 3 will send a query hit message to this node 2, and then what will happen is node 2 has obtained the addresses of 7 and 5 from 4 and 3 using the query hit, it will contact these two nodes and it will get the data, obtain the file. So, this is the decentralized way of working. The problem of decentralized is that it depends on flooding, and of course, it is very difficult to contain. Whatever way it is possible, it tries to contain the number of messages that are being created in the network, but it is not always easy to do that. So, the third model is a hybrid model, which is a two-level hierarchy, which combines the centralized and the decentralized models' good benefits. There are some nodes which are called super peers. These are the nodes which contain the indices, just like our first system Napster, and the peer nodes are connected to the super peer nodes. So, this is how the peer nodes will be connected. Every peer will be connected to some super peer nodes. A super peer can have a number of peer nodes. So, each super peer contains information, index information about the peers who are connected to that particular super peer. Therefore, all indices information are in a server, but there are a number of servers, and thereby reducing the problem of bottleneck and single point of failure. So, how does it work? Whenever some node wants to request, say this peer wants to request for a specific data, then it will send a request to its super peer using as shown by this line, and then the super peer will search in its own index, does any other peer have this data that belongs to this super peer. It will also send a query to the other super peers. The super peers are connected with each other, so it will send a query, and then the super peers will look into their own indices and will get back to the querying super peer with a reply. This reply will be sent to the peer who is asking for that information, and the file will get transferred finally from that peer to peer. So, CASA kind of thing has a hybrid model which combines the two mechanisms. Now, let us look at why we are studying P2P in a cloud for a cloud environment. Peer-to-peer techniques are used in two different ways. One is a storage. This is the most popular method of using P2P in cloud. Many storages are having the concept of P2P because it's easy to share resources. The other is, which is a rather recent concept, is that there is a P2P cloud that people are talking about, where we need to look at how a P2P storage or a P2P cloud compares and contrasts with the existing centralized models. So, in P2P storage, the peer is just any normal node that has some information. They want to act as a storage system. So, its own hard disk, its own CPU power, whatever resources they have can be shared, and these are connected over a WAN or a overall networking. So, if we compare a normal cloud storage, which is a centralized environment, data is stored in a server in a cloud storage, for example, Amazon S3 or Dropbox, and in P2P storage, data will be stored in any or all members that are part of the peer-to-peer network. Voila and Tahoe are typical examples, and there are many other recent P2P storages that have come up. So, what is the problem with the P2P storage? P2P is distributed over a large geographical region. So, as soon as we talk about distributing some centralized information, there are privacy and security, all these concerns will come. The P2P nodes are under the control of the user rather than the basic inherent cloud concept that it will be under the provider's control, and the peers connect through the through an unsecured network. So, therefore, the provider does not have any control on what kind of information over what network it is going. Absence of firewall, absence of a secure environment makes the data more vulnerable. Now, let us come to a P2P cloud. In a P2P, in contrast, what we normally have is a centralized cloud. So, in centralized cloud, we have a huge data center, one or more data centers, and the benefits that we have been seeing is that everything is one place and installation is easier to control and to some extent cheaper. Challenges will be the initial investment will be very high and the power requirements will be high and single point of failure, and the geographic, the natural catastrophes in a one region will be a problem. So, this is our centralized solution. How do we contain these problems? We have a decentralized data center. So, have many data centers, small data centers, and these data centers in a distributed manner can communicate with each other. So, if we look at P2P versus a centralized cloud, P2P is a decentralized model. So, a service provider has some money, they create one data center and start providing services. When they have more money or a requirement increases, they create another data center and they connect these two data centers as a P2P mechanism and do it. So, it is a geographically distributed multiple data centers environment. For one huge cloud, it is possible for one particular service provider like who has a huge money, but it is not possible for others. In a P2P cloud, small industries or individuals can create small data centers, and these data centers together can provide a cloud facility. So, typical P2P cloud has all the characteristics of a P2P environment, and many peer nodes which are the commodity, having commodity hardware, can be used for having a P2P cloud. It is unstructured in nature. Inherently, when we have a P2P cloud, we have an unstructured P2P environment. So, easily new nodes can be added, and the links between these nodes can be established arbitrarily based on all the requirements of the P2P cloud. So, it is a collection of commodity hardware. It has all the characteristics, it is loosely coupled, there is no specific hierarchy. It is unreliable because the same problems that the user, it is under the control of the user, and user uses a unsecured open network to connect. Heterogeneous in nature, no control again over the kind of machine that can be used, and each one will have a resource constraint. So, using P2P technologies, we can have an IaaS cloud. So, these are the benefits. Initial investment is not required, power consumption at each end will be low. The power can be supplied through different grids. So, we do not really burden one particular geographical location. Through different network connectivity, we can, different ISPs we can do. Single point of failure is not there. Challenges are that security and other risks are challenges. QoS is not guaranteed to that extent because of the problems that the peers belong to individuals. So, it is not appropriate for public cloud. It is suitable for a setup that already has so many resources in a private or a community cloud environment. To summarize today's module, we have looked at the P2P architecture. We already looked at the overlay architecture and the types of architectures, structured and unstructured. in which we have looked at examples of structured and some unstructured P2P networks depending on the types, and then we saw how the P2P technology is used. In the next module, we will continue with talking about other different aspects of cloud computing. These are our references. Thank you.